Hey guys, welcome to Complete Grade Solution. Question number 16 is what is the scalar projection of A vector on B vector? So scalar projection of A vector on B vector is nothing but A vector times B vector upon magnitude of B vector. Okay. So we have to find dot product of both these vectors. So we can write I to I, which is 4, J to J plus 8 and k to k plus 7. So 12 plus 7 is 19. By checking all these options, we can find that 19 is in the option number B. So we can say that option number B is our answer. Now question number 17 is if the magnitude of the sum of two non-zero vectors is equals to the magnitude of their difference, then which one of the following is correct? In this question, the scenario is like that if magnitude of A vector plus B vector is equals to magnitude of A vector minus B vector. So what about A vector and B vector? Both are non-zero vectors. So squaring both sides, we can get A vector plus B vector square is equals to A vector minus B vector square. So by solving these, 4 times A vector dot B vector is equals to 0. If A vector dot B vector is equals to 0 means dot product of two vectors is 0, then they are perpendicular to each other. So option number B, the vectors are perpendicular to each other, is the correct answer. Now look at the question number 18. Consider the following equations for two vectors A vector and B vectors. Three equations are given and which one of above statement are correct? Okay. First statement is A vector plus B vector dot A vector minus B vector is A square minus B square. This is the identity of dot product. So this one is correct. And simply we can say that if first statement is correct, then obviously second statement is incorrect, just because of product of two functions are not same in different ways. And the third one, magnitude of A vector dot B vector square plus magnitude of A vector cross B vector square is equals to magnitude of A square magnitude of B square. Yes, this one is also correct. So our answer should be option number C, which is first and third only. Okay. Now look at the other way of solution for this problem. Let's say A vector is I plus j and B vector is nothing but I minus j. Okay. So magnitude of A vector is magnitude of B vector is also root 2 and A vector plus B vector, magnitude of A vector plus B vector is 2 and magnitude of A vector minus B vector is also 2. Now substitute all these values in all three statements. Now first statement should be A plus B dot A minus B. So A plus B is A vector plus B vector. A vector plus B vector is 2i cap and A vector minus B vector is 2j cap. Product these two functions, we can simply get 0 because I dot j is 0. Now in the right side, magnitude of square of magnitude of A vector and magnitude of A vector is root 2. So square is also 2 minus 2. It is also 0. So first statement is correct just because of LHS is equals to RHS. In the second statement, magnitude of A vector plus B vector, which is 2, multiplied by magnitude of A vector minus B vector, which is also 2, that is 4. Difference of these values is 0, which is not equal. So second statement is incorrect. Now coming to third statement, A vector dot B vector. So A vector dot B vector is 0 plus A vector cross B vector. So A vector cross B vector is nothing but k cap minus 2. And after finding magnitude should be 2 and taking a square, that is 4. Now coming to RHS, magnitude of A vector is root 2, after taking a square is 2, and magnitude of B vector is also root 2, after taking a square it will be 2. So 2 multiplied 2 is 4. LHS and RHS are equal, so statement 3 is also correct. You can simplify this problem by taking any example like A vector is this and B vector is this. The answer is always remains same, that statement number first and third is correct. Now question number 19 is, consider of the following statement: the magnitude of A vector cross B vector is same as the area of triangle with sides A vector cross B vector. If we have a triangle represented by a vector and two vector of its two sides, so the area of this triangle should be half product of a vector cross b vector. Okay, so first statement is incorrect just because of it is given that magnitude of a vector cross b vector, but it is half times magnitude of a vector cross b vector. Okay, now coming to second statement, if a vector cross b vector is equals to 0, where is a and b both are non-zero vectors, okay, then a vector times a vector is equals to lambda times b vector. So if a vector cross b vector is 0, where a and b both are non-zero vectors, that means here theta, angle between these two vectors, is 0 degree. If angle between two vectors is 0 degree, then they are parallel vectors. And a vector and b vector are, if a vector and b vector are parallel, then a vector is equals to nothing but lambda times b vector, where lambda is a constant value. So statement number 2 is correct. So our answer should be option number B, which is only 2. Okay. Now question number 20. If a vector and b vector are unit vectors and theta is the angle between them, what is sine square theta by 2? First of all, we can solve this like that: a vector minus b vector square is equals to a square plus b square minus 2a vector dot b vector. As it is given a vector and b vector are unit vectors, so we can write this as a vector minus b vector square is equals to 1 plus 1 minus 2 times a vector dot b vector is magnitude of a vector, magnitude of b vector, cos theta, where theta is the angle between these two vectors. Sin square theta by 2 is equals to 1 by 4 square of magnitude a vector minus b vector. So option number B is our answer. There are too many methods to solve this problem. So in other way, we can assume that, let's say a vector is equals to I cap and b vector is equals to j cap. If a vector is I cap and b vector is j cap, then theta is equals to pi by 2. So sine square theta by 2 is now nothing but just half. Now putting all these values in options, so we can say our answer should be option number first or option number second. Option number C and D should be cancelled out. Now again, taking a vector is equals to I cap and b vector is also I cap. In this situation, the angle between these two vectors is 0 degree, and sine square 0 now should be 0. When we satisfy these two values in these options, so option number B satisfy all these conditions and option number A should be cancelled out. So our answer should be option number B. Now question number 21 is, the equation ax plus by plus c is equals to 0 represents a straight line, then which one of these options is correct. Okay, if ax plus by plus c is equals to 0 represents a straight line, then what should be the values of a, b, c? According to first option, a, b, c are real numbers. So if a, b, c are real numbers, then it represents a straight line. No doubt this one is correct. Now option number b is only when a is not equals to 0. If a is not equals to 0, then maybe b is equals to 0, because there is no condition about b and c, so our equation is just like ax plus c is equals to 0, and this also represents a straight line. Same as option number c, this one is also represents a straight line. Now coming to option number d, only when at least one of them is 0. So all these options represents that no matter what are the values of a, b and c, we can draw a straight line if at least one of them as a variable. So option number d is exactly correct value. Now question number 22 is, we can assume here any value for alpha, beta and a. So we assume that alpha is equals to beta is equals to pi by 4 and a is equals to root 2. So we can form these equation in a simple pattern. So after substituting these values, we can get first equation is just like x plus y is equals to 2, and the second equation x minus y is equals to 2. So if we draw graph of these values, so first graph of first equation should be like this, and the graph of second equation should be like this. The intersection point of these two lines is 2, 0. Okay, as we notice that these two lines are equal and these two lines are equal, so this one is pi by 4 and this one is also pi by 4. So angle between these two lines is exactly equals to pi by 2. So now substitute all these values in all options and find that which option satisfy pi by 2. So first option not is our answer, because of as alpha and beta are equal, so alpha minus beta is equals to 0, not equals to pi by 2. So first option is not our answer. In the second option, beta minus alpha, that is 0, and pi plus 0 is pi, not equals to, again not equals to pi by 2. Option number C, if alpha and beta are equal and both are pi by 4, then alpha plus beta should be pi by 2, and 2 times of alpha beta is pi plus pi upon 2, that is also pi, not equals to pi by 2. So option number C is cancelled out. So obviously option number D is our answer, but check it once. Pi minus 2 alpha plus 2 beta, so sorry, pi minus 2 beta plus 2 alpha, so 2 beta is pi by 2, nothing but pi by 2, plus 2 alpha is also pi by 2, so this is cancelled out, and upon 2, which gives us pi by 2, which is equals to pi by 2. So option number D is our answer. We can simplify this problem by taking any value of alpha, beta and a. Now question number 23 is, what is the distance between the point? Let's say alpha is equals to pi by 2 and beta is equals to 0. Okay, so now coordinate of P is P minus M 0 and Q is M 0. Okay, so now distance between these two points is PQ, that is equals to root 2m square plus 0, that is equals to 2m. Now putting all these values in options and check out which option satisfy these conditions. So in the first option A, 2m sine alpha minus beta, means pi by 2, and sin pi by 2 is nothing but 1, so it is 2m. Option number B is equals to 0. Option number C also 0. Option number C is also 0. So option number A satisfy all these conditions. So option number A is our answer. Now question number 24 is, an equilateral triangle has one vertex at -1, and another vertex at -√3. So third vertex may be lie on which coordinate? So as it is given triangle is an equilateral triangle, so all these sides, all three sides are equal. So if we use first or second option, so we can say that these are not going to our answer, just because of we can't simplify √3 and √2 as √2 and 1, just because of as we taking √2 and √2 as our answer, so it will going to be 5 plus √6 type something, and when we solve this with 1 and 1, it should be 3 plus √2 type. So these are not going to be equate in any situation, so we can take option number C. Just put 1 and 1. This side should be √8. This one is also √8, and this one should √8. All three values are equal by 1 and 1, so we can say option number C, 1, 1 is our answer. Now question number 25 is, if angle between the lines joining the end points of minor axis of ellipse with one of its foci is pi by 2, what is the eccentricity of the ellipse? Okay, these two lines is pi by 2, this angle, complete angle is pi by 2. Okay, as we know that in the ellipse these two sides are equal. Okay, this one is the bisector, even perpendicular bisector of this line, so this angle is also bisected. So this one is pi by 4. If this is pi by 4, then these two lines are also equal, so this length is represented by C and this length is represented by B, so we can say B is equals to C, and the relation among A, B, C is A square is equals to B square plus C square. So we can say A is equals to √2 times C, and the eccentricity of the ellipse is nothing but E is equals to C by A. So A is equals to C upon √2 C. So option number B is our answer. Now question number 26. A point on a line has coordinates p plus 1, p minus 3, √2 p, where p is any real value. What is the direction cosine? Okay, as we notice p plus 1 represents x coordinate of this point, p minus 3 represents y coordinate, and √2 p represents z coordinates. So after solving all these values, we can say x minus 1 is also equals to p. So we can write this just like x minus 1 is equals to y plus 3 is equals to z upon √2, and all these values are equals to p, where p is a constant value. So we can write this in the form of Cartesian form of a line. So taking observation 1 and 1, so direction ratios of this line are 1, 1, √2. For converting these direction ratios in direction cosines, we can divide all three values by square root of their squares, means 1 square plus 1 square plus 2, which is 4. So the direction ratios of this line is 1 by 2, 1 by 2 and 1 by root 2, means option number first. Now question number 27 is a point on line has coordinates. Okay, let's say equals to lambda, which is a constant value, so x coordinate of the point should be 1 plus lambda, y coordinate should be 3 plus 2 lambda, and z coordinate should be minus 2 plus 7 lambda. Okay, so what is the possible value of lambda? By hitting all these options, in the first situation x coordinate is 3, so if x is 3, according to option number A, if x is 3, then we can find that lambda is 2, and we substitute lambda in other two values, other two coordinates. We can say now z is 2 to the 4 plus 3 7, which is not equals to 5, so option number first isn't answer. Now option number second, according to option number second, x is 2, so lambda is nothing but 1. If lambda is 1, then y coordinate of this point is 2 plus 3 5. Yeah, it is equal, and z option is again 5, so 2 5 5 satisfy this condition, so option number B is our answer. Question number 28 is if the line x minus 4 upon 1 is equals to y minus 2 upon 1 is equals to z minus k upon 2 lies on this plane, then what is the value of k? Okay, so again let's say these values are equals to lambda, so x coordinate intersection point, so x coordinate of the intersection point of this line and this plane is 4 plus lambda, y coordinate is nothing but 2 plus lambda, and the z coordinate is nothing but k plus 2 lambda. Okay, this is the coordinate of intersection point, so it will also satisfy this, the equation of the plane. So 2x is 8 plus 2 lambda minus 8 minus 4 lambda plus k plus 2 lambda is equals to 7. So after solving this, we can get k is equals to 7, option number D. Now question number 29 is a straight line passes through the point 1 1 1, makes an angle 60 degree with the positive direction of z axis. Okay, and the cosine of the angles made by it with the positive direction of the y-axis are in the ratio, y-axis and z-axis are in the ratio root 3 times root 3 ratio 1. What is the acute angle between these two possible positions of the line? Okay, as we know, direction cosine of a line are L cos alpha, M cos beta and N cos gamma. So the angle between the line and z axis is 60 degrees, so we can say the value of N is nothing but half. Okay, and the direction cosine of x axis and y axis root 3 times root 3 ratio 1, so we can say this one is, so as we know that the relation between direction cosines is L square plus M square plus N square is equals to 1, so P square plus 3P square plus 1 by 4 is equals to 1, so 4P square is equals to 3 by 4 and P square is equals to 3 by 16, so P is equals to root 3 times 4 plus and minus. Okay, So direction cosines of first line should be root 3 by 4, root 3 by and half, and the possible direction cosine of line second are minus root 3 by 4, minus 3 by 4 and half. So angle between them is cos theta, which is nothing but product of these two direction cosines, which is minus 3 by 4 minus 9 by 16 plus half. After solving this, we can get minus 8 upon 16, which is equals to minus half. So angle between them is cos theta, means theta is equals to 120 degree, but we have to find acute angle between them, so this one is 60 degree. So our answer should be option number B. Now question number 13, last question of this part, is if the points x, y minus 3, 2, 0 minus 1 and 4, 2, 3 lie on a straight line, then what are the values of x, y, z respectively? Okay, let's say the equation of a line passing through 2 points is nothing but x minus x1 upon x2 minus x1 is equals to y minus y1 upon y2 minus y1 is equals to z minus z1 upon z2 minus z1. Okay, so the equation in this situation is, let's say this is x1 y1 z1 and this one is x2 y2 z2, just because of all these values are given. So the equation of line is, so here z is minus 3, so substituting this value in this point, so this one is minus 3 plus 1 upon 4 is minus half. So first time x minus 2 upon 2 is equals to minus half, so we can find x is equals to 1. In second situation, y upon 2 is equals to minus half, so we got y is equals to minus 1. So x and y is nothing but 1 and minus 1, which represents option number A. So option number A is our answer.